video, I want to talk about the concept of general planar motion. So general planar motion is the idea that a motion of a rigid body can be thought of as a breakdown of various other types of motion. So before I get into that in more detail, I want to explain where we've been so far. So far we've talked about translation, and within translation we can think about linear translation. So linear translation is an object moves from one position to another, and as that occurs, a point on that object, which I've arbitrarily identified with this circle, travels in a straight line between those two locations. We've also talked about curvilinear motion. And in curvilinear motion, we get the same general thing, that an object moves from one location to another, but now, perhaps as it moves between those two locations, it travels along some path that's not represented by a straight line. We've also talked about fixed axis rotation. So fixed axis rotation involves our rigid body moving from one position to another about some central rotational axis. So in this case, my identified location on this rigid body travels along a path, a circular path, that traces a circle around that axis of rotation. Similarly, I can have a rigid body that rotates around an axis at its center or at any other point, and a point on that body translates again in a circle around that axis of rotation. So when we think about general planar motion, we can think of it usually as some combination of these various types of motion. And as an example, suppose I have the ground, and a wheel is rotating, rolling across the ground, and it goes from one position to another. And how this moves depends a little bit on where we look at the wheel itself. So if I was looking at the center of the wheel, right in the middle, I would see that I have a translation from one spot to the next, which follows a straight line. Now, however, if I looked at a different point on that wheel, so for example this circular location, and followed that or traced it as it moves from one location to the next, I would find a path that looks quite different. Perhaps something like this. So if we want to analyze the motion of this wheel, we might break it down into different components and refer to this as general planar motion. So it's a motion that involves both translation and rotation in this example. So if I wanted to do that, I might break this down such that the wheel is doing two separate things that I independently evaluate. First, it is translating from the position on the left to the position on the right. So it's undergoing some translation. And then, once it gets there to this new location over here on the right, it undergoes a rotation about its center to whatever orientation it ends up in. So when I put those two things together, I can go ahead and evaluate that problem with some of the tools that we've already seen and some of them that we know well. So let's take a look at another example of how I might look at this. Suppose I have a rigid connecting beam attached between two sliders, and I've drawn them a little too close together probably, but these sliders are contained within slots, fixed slots, such that when one of these sliders moves, so for example this one moves down, because of the rigid linkage between them, the one at the bottom has to move to the right, and that's the only way it's possible for it to move. So let's call this one B and call this one A. So I can represent the motion of this link between the two, the link that connects A and B, as a translation. So for example, I can represent it this way as a translation to the right. So I would call this a translation of point A. So if I slide this linkage shown right here to the right, of course we know that point B cannot move to the right because it's constrained to be within this slot. So for this to be true, after I've in an imaginary sense slid this linkage to the right, I have to rotate B down in order to bring it back into line in alignment with the center of that slot. So to this I would add, let's draw this in a different color. To this I would add a rotation about point A. And in this way, I'm able to represent this motion via two steps that are that we have that are pretty well defined in terms of how we handle them, and apply my analysis that way. Now, of course, this isn't the only way that I could do it. I could also first apply a translation of point B. So again, I'm looking at my linkage and I'm saying, well, let's translate the whole linkage down, which we know, of course, point A cannot physically do, but we're going to start by saying that we're going to translate point B and take point A with it. And then we'll add to this, in order to make it physically possible, we'll add to this a rotation then about B. So if this is my starting point, my ending point indicates that A had to move up, so I'm translating in this direction. And I'm doing a fixed axis rotation about point B. So combining these two things together, I'm able to recreate the actual motion. And now I have the ability to use my common tools, the ones that I already know, in order to analyze the situation. Thanks.